All right, folks, I'm going to show you an example of how to do 16.2. This is going to be drawing on our normal curve work from chapter 12. So what we're looking at is how do you get these critical values, the numbers that you're multiplying your standard error by. So just heads up, the formula for estimating the population proportion is to use your sample proportion, p hat, and you're adding and subtracting a critical value, which we're about to discuss, times your standard error. So please go ahead and write down this formula somewhere that you will be able to find it and keep it. So just a couple of vocab things. The thing you're adding and subtracting from your statistic is called the margin of error. It's the amount of space you're giving yourself when you wiggle above and below your statistic. Just this guy is called the standard error. And this guy is your critical value. So margin of error is made up of critical value times standard error. And that's where you're adding and subtracting from the middle. So you are starting with some number, that is your statistic, and you're allowing yourself to go above and below that same amount. So this is your margin of error, and E for short. So plus this way, minus this way. All right, so we're going to be working on critical value with this problem, so we're figuring out where does this number come from. Now heads up, when you're done with this, the numbers you're about to get, you're going to use for the rest of the chapter and for a while. So once you've done them once, you don't have to redo them. But I'm going to be walking you through how to find a 98% confidence interval. So that's part A. Okay, so if I want to be 98% confident, this is where that number comes from. That the name of your variable, the parameter, the thing you're estimating is between low and high value. So low value being what we got when you subtracted, and the high value added. So how do we get the 98% of the question? So to get A, we're drawing a normal curve. And we're going to be shading or imagining the middle of 98% of that. So we're going to say 0.98, and for good measure, I'm going to add some zeros. I would like 98% of my data to be in the middle. If that's the case, I am currently missing 2% on the left and the right. If I'm missing 2%, half of that, 1% is on the left and 1% is on the right. So this is the hard part, 0.0100, 0.0100. So now this graph should add up to 1. We're using the standard normal curve for this. So I'm shading the area, the middle 98%. I don't know. What's your middle 98%? 98% here, 2% missing, half here, 1%, 1%. The reason this is important is there's going to be a z-score here and a z-score here. They're going to be the same size, but this one's going to be positive, this one's going to be negative. And whatever that is, that's your critical value. So the way you look this up is you want to use your table. I'm looking for, now my table is not good at middle. What it can do is do less than, right? So I'm going to be looking for 0.0100 on this side. This is a really hard one, but I think this one's closer. So I'm going to say that my z star is, my z is negative 2.33 to make my lower left tail be 0.0099 or close to 01. So I'm saying this is negative 2.33. Now, in B, it's asking you to think about something a little different. So this was, I looked up this one, right? And that got me the negative 2.33. Now, if you want to just walk through this again, I don't like doing this twice, but just, they're asking you to think about what this number would be. And for the upper one, right? So this is 98% plus 1%. So this would say 0.9900 if you wanted to look up less than this one. Now, you will find this to be hopefully unsurprising. But if I look for 0.9900, I've got these two options. This one's closer, so that's 2.33 positive. And this works because normal curve is super symmetrical, so both of these are 2.33. This one's positive, above average. This one's negative, it's below average. So the idea is, how many simulations away from the middle do you have to go to get 98% of your data? And the answer is 2.33, left and right. So the critical value is 2.33 standard deviations away from the middle to capture 98% of the data. So I found to get to be 98% confident, I would like to shade 98% of the middle of my graph. I have to go 2.33 standard left and 2.33 standard right. So that's going to be the number I would end up using here. So I'm going to be multiplying the standard error, our estimate of standard deviation, times 2.33 to be 98% confident. Now, fun trick, I like this one, but it can be very, very dangerous if you don't do this middle thinking step. So to get this 010, what I did is I did 1 minus the confidence level divided by 2. So I did 1 minus 0.98 over 2, and that's what got me the 0.01. The 0.01 is critical. If you don't have that, you can't really do this next thing, so just be careful. It can be very dangerous. It's showing us how to do this on the calculator. I kind of like this. You're looking for something called inverse normal on the calculator. I'm going to ask it about 0.01. So the number you're putting in here is what you get from this formula. So this is to be found in, this is the button, but it's actually distribution. So I'm going second bars, the distribution, and I want inverse normal, which is option number 3. And what happens when you get in here is it asks you what is the area that you'd like to shade. So I'm going for 0.01, right? I'm shading 0.01 to the left. And I wouldn't mess with these. And it should tell you what we just found out, negative 2.33. I would have to round that up. So that's how the calculator does that. So if you want to write it down, negative 2.326, but you have to round it. You're going to drop the negative sign, because this is the left and you also need the right one. So either way, conclusion is 2.33 for Z star. And then if you wanted to do the upper one, you would do the same thing. We do inverse normal for 0.99. And again, there's a bunch of thinking that needs to happen to get that number, right? I gave you 98%. That's not what this was. That's not what this was. So you need to be very careful. Okay. So that's how that works. And I'm going to be asking you to try that again for D. You're doing a 95% confidence interval. Very important. This is the most common one. So do the same thing with a 95% in the middle. And then when you're done, go ahead and copy the chart at the end. Put it somewhere on an index card where you'll find it, because those will be the numbers you use a lot.